My name is Nicholas. I'm here with my colleague Stephanie. Today we're going to be going over some low-code machine learning on Databricks, mostly focused around AutoML, but we're going to show you a few other cool little low-code tools that we have in our toolkit here. So we're going to start off with the safe harbor statement. Everything we're going to be talking about today is for informational purposes only. Please, make your business decisions off things that are currently available, services, features, functions. This is a really cool informational demo. So with that being said, I actually would like to start off with a little bit of a personal story. This is a personal kind of machine learning journey that I've been on, and I think it kind of sets the stage for what we're going to talk about, and it kind of encompasses a lot of our ideals and things behind the methodology behind the tools we're going to show you. So I started my career 6-7 years ago in the aerospace field. So I actually worked as a part of a team that trended fleets of military jet engines, right? And what that meant was we'd basically take jet engine data from all over the world, streaming, batch data, would bring it all in, would run it through machine learning models. Those models would come up with either alerts or everything's good. We would also report back to those fleets and tell them which engines to look at, what might be wrong and why. It's interesting. As part of that group, I had a mentor. His name was Chuck. He is the epitome of a domain expert. This man knows more about jet engines. He's forgotten more about jet engines than I've ever learned. He could take raw engine data and he could tell you a story about it. He could tell you the efficiencies, right? Just an absolute beautiful mind when it comes to jet engines, right? And the way our workflow kind of ended up going is he would, let's say that a new alert came from the field, something new happened that we hadn't seen yet before, and we wanted to build a model around it. Chuck would pull me, a couple of our other group members into a room, would go in front of a whiteboard. He would explain to us all of the equations that went into it, right, into this new failure mode. He would explain to us that, these sensors are the ones we want to look at. He would do his version of feature engineering, tell us what to look for, right? And we would take this knowledge, we would actually go into the databases, would start creating these features, and would start the sometimes weeks-long process of both training, optimizing models, and then actually getting them put into a development system that scaled from one model that we could test to the thousands of engines that come through every day. So the way that it normally worked is that Chuck had his very, very brilliant mind. He had a lot of knowledge, but Python and the new coding practices weren't necessarily part of his toolkit, right? But they were a part of mine. So there was often this back and forth where he would have to give me knowledge, I would have to take that, I would have to kind of turn in the features, turn those features into models, turn those models into pipelines, deploy those models, make sure all of those were working, if something ever went wrong, why, what went wrong with the data, etc. So, while this worked, it's kind of hard to scale, and it would have been really nice if both of us kind of had tools to help us essentially do our jobs quicker, right? And so that's why I want to frame our whole talk around kind of the question of, does applying machine learning have to be a challenge, right? And so we're going to go through, just some general, I don't want to say hurdles, but things that generally people have to do in order to apply machine learning, right? First, you usually have to do some kind of exploratory data analysis. You have to understand the data. You've got to be able to see what you have, see what you can make features out of, and understand kind of the nuances of your data. With that kind of comes software development skills, a lot of Python or SQL. Then you get to the model training and optimization part, right? So now you've got your data, you may have generated some features, but you actually have to make models out of those. And you can't just make any model. The model's got to work, right? It's got to be pretty accurate. If you go and tell somebody that their multi-million-dollar engine is broken, they go and look and it's perfectly fine, you're going to lose trust immediately, right? So accuracy was huge. You have to then deploy and host these models. You have to track the models in case they become inaccurate or the data behind them starts skewing. And then you have to do all of this at a production level scale, right? If you have one engine, yeah, that might not be so hard, but now you've got thousands of engines, they're all running at different times, you're getting data from different places, right? It's a challenge to scale this kind of thing. So at Databricks, we have tools that cover a lot of these different aspects, right? And here's a lot of them. We're not going to go into every single one now, but I just want to make everybody aware that we do have a lot of different solutions here. Today specifically, we're going to be focused mostly on AutoML because we want to kind of show how we can lower the barrier to entry, right? How we can make it easier to do a lot of these things. So if we zoom out one step further, all of these things you see in front of you all fit into our vision of the lakehouse, which we see as the foundation for all your data analytic needs. So you'll see we have data science and ML as a box, but we also cover all sorts of different things. And I'm sure throughout Summit, you've seen all different talks about data engineering, data streaming, data warehousing, all of the really awesome new announcements at the keynotes. So hopefully you're a little bit aware of everything inside this lakehouse. Oh, nice.
Wrong way. All right, so we've talked about how all the things that go into machine learning, we've talked about how it fits into the lakehouse. So how does this fit into low code? Well, quick question. How many here are excited about low code? Come on. Yeah? Awesome. How many here are skeptical about low code? Yeah. Yeah. Me too. As a practitioner, low code was scary at first, and it still is in a lot of ways. I'm going to go the wrong direction again, aren't I? Let's see if I can be smarter than the slides. All right. Awesome. So we spend a lot of time copying and pasting. I mean, you think about how many times you've looked up specific syntax, not because, you don't know how to do it, but maybe you were using R, now you're using Python, or now you need to change your axes to do something else. So we spend a lot of time doing things that people are not really built for, that they're not really that good at. So instead of wasting our time doing things that could be automated, we could be spending our time doing more human-related tasks. So we have 3 main tools at our disposal that we're going to talk about today that really makes dev life easier. So we have your platform data scientists and engineers that are moving at a faster pace than ever. They're trying to get through and get their job done in a faster way without the headache and the mundane tasks. And then we also have another group of folks that maybe are R specialists, SAS specialists, Excel specialists. Maybe they're Chuck. And so they have a lot of experience and domain expertise that they can bring to the table, but they don't code in Python. So the first of the 3 is AutoML. And a lot of our competitors will tell you that AutoML is going to replace your data scientists. It's going to democratize machine learning so everybody can do it. And here at Databricks, our philosophy is more along the lines of, we don't want to replace anybody. We don't think that that's even makes sense. We're here to empower people, make them more productive, and we believe in a glass box approach. I'll talk more about the glass box approach when we get to our demo. Our next friend is MLflow. So reproducible research means that every single step of every single experiment is tracked. So the headache that many of you know, what are my parameters? What are my features? What algorithm did I use? What came out of that? What was my evaluation metric? What if I've changed my evaluation metric and now I want to look at something else? All of those pieces, for me, used to live in spreadsheets of chaos before MLflow. So now MLflow is your girl's best friend, right next to my dog. And then last but not least, Bamboo Lib. Super excited for this to be public preview in our product. It's been living around for a while through the acquisition of 8080 Labs. We now have it integrated within the notebooks of Databricks, but it's much cooler in action than it is in a slide, so let's just jump to the demo. So today we're going to do a demo a little different. My friend Nick here is going to, I don't know what we're going to call this. He's going to be the marketing guy, that he is technical marketing, and I will be the data scientist, and we're just going to go through it. We'll see how well.
I'm going to be the guinea pig. That's the official term.
Awesome. So if we could just start by opening up a notebook, that would be great.
Cool. And we're gonna call this one. We'll just call it AutoML.
And so we want to make sure that we pick a cluster that has 11.0 because as public preview for Bamboo it's only available in 11.0 ML runtime.
Pay a little homage there.
That's good.
Yeah.
Awesome. So now let's just go ahead and import Bamboo as BAM. And then BAM, and then it'll start up. Gives it a few seconds to let it warm up, start the UI up. And from there, we have a couple of different options. Let's go ahead and load a database table. Today, we're going to look at COVID hospitalizations.
All right, cool. So I can go Data AI Summit, right? I can just go ahead and grab. It's this one, right?
Yep.
Perfect. All right, for row limit, we want to bring in all the data, right?
Yeah, we want all of our data. Let's not put any limit in. Go ahead and execute.
Ooh.
Nice. So while that's loading up, you'll notice we have a pretty good menu here of different things you can do. We have history. If you want to look at the history of your actions you've done, you can export it. There's a whole list of...
You gotta love live demos, right? So if you're real observant there, you notice I put a 0 instead of leaving that box blank. I limited it to 0, so we brought in nothing.
Wow, at least we know that works. All right, so let's start with a basic action. So in our search actions, you can go ahead and see, we could rename a column. And so entity is clearly a country, so let's just go ahead and rename that one to show how easy that is. Nice, happens right in line. You'll also notice that there is an O next to all these different column names. That's because they're considered to be objects. But if we're working with time series, we need to make sure our date is actually formatted as a date, not a time series. So if you want to go ahead and click on that, instead of I'm Googling the syntax to make sure I know how to transfer my date from one type to another, we're going to go ahead and let the default just take care of that. Nice. Excellent. So if you want to go ahead and take a look at date, if you click on it, we can explore it a little bit. Nice. No missing values. You can see that we have a pretty good number of data points over the course of time. A little shy on the edges, not to be too worried about that. And if you click it, looking at it over time. No, I lied, that's not a thing. The bivariate plot, that's what I'm looking for. There we go. Okay, so this is what it looks like over time. And so if you want to go ahead and change it from country to value. So here we can kind of see that there's some waves. They're not very clear or distinct at this time. And part of that has to do with we don't even really know what value means.
There's one other catch here. Value currently is still considered an object.
Oh, well, that's a problem.
So if we make value a float, because it is a number, and then we go back, what we should see, if we go back to our time series.
Oh, wow. Look, now we can see some COVID waves. That seems to make a little more sense. Nice. And instead of having to go back and forth, copy and paste and move my code and not remember which one I kept, Bamboo Loop's going to help with that. So if we go back and take a look at our data, we really want to understand what exactly is value. What are we looking at over time? And if you notice the indicator column, it actually is a lot of different things. And if we're looking to predict something, which today we're hoping to predict, the waves of COVID over time, we need to make sure we're looking at a single metric. So if you want to go ahead and click on the indicator column, you'll notice that there's lots of different ones in here. So we're going to go ahead and filter it down. So if you go back, we can do our actions. Filter. Excellent. We'll go ahead and select the rows that are daily hospital occupancy. Isn't that nice? You don't have to write it down, fill it in, auto-populates. I love that.
As someone that's written a lot of SQL in their time, I will take this. I will take this any day.
Awesome. Happened real fast, real solid there. Okay. You'll also notice we got a number of different countries here. So particularly, as we are in the United States, we'll take a look at the United States. So if you could filter one more time for me.
Sure thing. Let's choose select rows, countries, has value, and United States. Execute.
Awesome. So if you scroll down a little for me, I want you guys to notice that the code for this is building. So it isn't that this is some GUI that then is lost. After this, we have not only the code to reproduce it and share with our team, but it also is commented better than I would comment my code. So if we want to go back up, it looks like we have just about everything we need to go ahead and predict this. So let's actually write it out to a table.
I love this. All right, so database, we've spooled one up for Data and AI Summit. And then let's call this US, and what is this? Daily Hospital. COVID daily hospitalizations. Okay, no, make fun of me if I spelled that wrong.
That's why you're typing and I'm not.
All right, we'll go ahead and execute that. So all this data should now be stored in a table.
Now, before we move on, if you want to just go ahead and copy the code and paste it into a cell, that way when I'm reviewing your code later to know how you did this, I have all of everything I need.
I don't even have to do that. There's a button. How kind.
Excellent. Okay, we now have a data set that we can work with. So you all came for AutoML, right? Let's jump over there. If you want to start a new AutoML experiment, that would be great.
Yeah. So over here on the left-hand side, right, just want to point some stuff out. Within Databricks, there's kind of different personas that we can cater the UI to. Right now, we're in the machine learning tab. So with being in machine learning, we've got some nice little options here. You see experiments, feature store, models. Kind of gives us some more fun tools to play with. So we're going to jump into the experiments tab, and we're going to create a new AutoML experiment here. So we're going to pick the cluster we've been working on. The ML problem type, in this case, we're trying to predict in the future, right? So we're going to do forecasting. You'll see on this right-hand side is actually something that I like a lot. For every Databricks runtime version, it shows you what's been improved in AutoML. So you can always know, A, that if you're on the latest, or if you need certain features, what Databricks runtime you need to be on. So that's always nice. So we picked forecasting. We're going to select our data set. US COVID daily hospitalizations. That's definitely spelled correctly. Prediction target in this case is going to be our value column. Our time column is aptly named date. We're going to predict 10 days in the future. And we're going to select the same database to output our data to. And we'll leave the auto-generated display name as it is.
If you want to take a look at the advanced configuration, we can see that there are other options. It defaults to a specific evaluation metric. So if you're not sure what to use, the default's a real solid one to go with. However, there are other options if you want to get a little more advanced with things, as well as you can limit your training frameworks if you wanted to remove profit or something along those lines to speed up your AutoML experiment. So if we want to go ahead and actually, I ran one before we came in here, so if we want to go ahead and open that up, that would be great.
Sure. And then one thing that I do want to point out that Casey actually said earlier, the timeout is nice because as she put it, well, if you have 30 minutes to run to lunch, right, you can set your models up to go train them for 30 minutes, set go, come back, and you know that they'll be done.
Oh, and even better yet, if it's stops early, it won't run the full 2 hours. If you run it and then it is not making any sort of incremental improvement, it's not going to waste time continuing to spin its wheels. It'll stop all on its own.
So let's just show real quick what it looks like to launch this experiment, and then we'll go into the one that we've already run right before this, right? So if you go in here, it'll start training. And a big thing that it'll do while it's training is it'll also tweak hyperparameters for you, right? So it does a lot of the experimentation for you, which is very, very nice.
Wait. So I don't have to run it 5 million times with different parameters?
You don't have to, but it will for you.
Oh, excellent.
So let's jump into an experiment that we ran before the session so that nobody has to wait. And here are the results of the last run. So you want to walk us through what we're looking at here?
Yeah, so actually, You'll notice that there is a view best notebook for model. There's a view data exploration notebook. Those are going to be what you see at the very end, although the exploration notebook starts at the beginning. So let's actually start there. So if you want to click at that and look at that real quick. This is what I meant when I said glass box. There isn't a black box. We're not going to hold your stuff hostage. We're really just trying to make you more productive. Remove the mundane tasks. This is all completely auto-generated, handed to you. Free code. Who doesn't love free code? So this is just to help get you started. Take a look at your data, visualize it. This is free for you. Take it, put it in Get, use it over again. Or if you don't want to, generate another one. I'm going to go ahead and back over to our experiment. Yeah, so each one of these runs is an experiment. Has all of its own parameters, has its own evaluation metrics. Each one of those has a notebook. Let's go ahead and look at the best notebook though. Yeah, best notebook. Again, auto-generated code. We're not looking to hide what we've done. We're not looking to keep you from doing this in another environment. If you want to take this and run this somewhere else, please do. So go ahead and scroll through it. You can just have a look. It's showing you all of the steps. Every single piece of what's happening is here for you to tweak, to do what you like with.
And to kind of tie this into the story that I started this off with, the way I see this really fitting in is somebody like Chuck with a lot of domain knowledge, right? But maybe not a lot of Python expertise, right? He can go in there and click around and he can set his data set up. He can make his features if he needs to, right? And now he can experiment. He doesn't need to know how to apply an ARIMA forecasting model. He doesn't need to know how to write all this specific code. He can just try, right? And now that he's got results, right, he knows enough. He knows enough to understand what accuracy is, right, and what certain machine learning metrics are. So if he gets something that's decent, right, he can now pass this off to me. And now I don't have to start from scratch. I don't have to generate the features. I don't have to go hunt for this data. I can just go ahead and take the notebook that he shared with me, and I can start the next step, right, of getting this out to the either deploying a model or further, right? And on top of that, I can look through this notebook and, through nice graphics like this, right? I can see that, oh, wow, this was actually a pretty good stab. So what you're looking at here, right, is the past 3 or so years of COVID data. And if you look really close at the very end, right, these are the last 10 days that we've now predicted out, along with the little error band, right?
Yeah, so then you can take this, clone it, put it into your Git repository. It's now your best model. You have a really solid place to start. And then you can give it to your data scientist to do any extra things with it that you need. So if you want to go back to the experiment, let's actually take a look at one of the runs. Let's look at the run for our best model, which if you click under start time, this is our model here. So it's going to have parameters if you have them, and if you want to expand the metrics, you can see that we had a particular evaluation metric we were interested in. That may have changed. So auto-logging with MLflow is really nice because it's going to just keep track of things for us in case we're interested in more than the metric we started with. Down at the bottom, we have all of the information we need to reproduce this. We have the environment, we have the model itself in case we would actually want to deploy it out to a Kubernetes cluster or something. And then we also have all the information to understand the model, inputs, outputs, etc. So let's actually register our model to the model registry. So the model registry is like Git, but for your models. It stores all your versions, keeps track of what's been reviewed, what hasn't been reviewed, and whatnot. You can, whatever you want to call it. You can pick one I've already done. That way you can see.
Sure.
While that's loading up, you can see that it's, yeah, there you go. You can click in there and see. It's not only going to keep track of this current version that we've just added, but you'll notice it's version 4, which means all the previous versions are still there. So when we move something into staging or into production, we're not actually losing our history. And so if you want to click on the model, oh yeah, thanks. So first, before you put it into production, you should probably make sure it works. So first we're gonna request for it to go into production or staging or whatever you like. You would wanna make sure that somebody's looking at this. There's a human in the loop. A lot of times we suggest that before you move it into staging, you would run a automated job. Check for descriptions, check for basic accuracy, make sure the model has prediction, actually predicts something, which is good, and a lot of those different kinds of things. So we'll say that the job is run, we'll go ahead and approve that.
Cool.
You can have a webhook actually approve that for you, which is really nice. And then before actually moving it in to production, we're gonna be sure his favorite data scientist. We'll make sure that everything looks good before we push it into production. We'll check it against business metrics and things. And then we can go ahead and move that into production. If you want to just straight move it over.
Yeah.
Yep.
So I happen to be an admin, so I can just approve myself here and push this right off to production. And to kind of still tie this back into the main story, right? Now we've kind of transitioned from what was helping Chuck to what would have helped me, right? I had to deal with a lot of different models. Some of them could have been old, some of them could have been new models, but they were all, either compiled from, some C# code that we had written. There were some Python stuff, right? God, we even had some models and some features being generated in stored procedures in MS SQL, right? Like things were all over the place. Whereas here, it is just in one place. If somebody wants to give me a new model to test out, to look at, I can just go, I can look at it, I can look at the inputs and outputs, the metrics associated with it, and I can just approve or deny and move on with my life. So it is really nice having all of this in one place. So now that we've got this model in production, can we do something with it?
Absolutely. So, like we all love auto-generated code, let's take a look at what it looks like to do inference with this model. So you have two options here. You can do a batch inference, so that for those of us who are not super familiar, is essentially a notebook that you run, you make predictions off of data, and store it into a table where you can use it for dashboards and things of the like. The other option is the real time. And so that's done using an API that's on a VM for you that can hit all of your applications, can come and get that. I'm sure you all saw that in the keynote today that we've actually scaled that up to version 2.0. So for our more massive customers who hit those APIs at a much bigger scale.
And that's the serverless model endpoints that you've been seeing in the keynotes, and the things that guarantee super low latency and high availability SLAs. So,
however, predicting the COVID waves isn't something I need to do in real time. So if we could just go ahead and do a batch inference, that'd be great.
all right.
You'll notice that you can pick from different versions of the model here. We're going to pick the version that's in production, since I just spent all my time reviewing his code.
We're going to take the production version 4, yep, and use model for batch inference. And now we get
auto-generated code. And it may sound like I'm really beating on that, but if you've done my job, if you've been a data scientist, the last thing you want to do is copy and paste your notebook one more time just to change the pieces in it to make it run again for a different problem. So this has it already done for you, and you can see all the different pieces of what it does. You can save those predictions out to a table and continue on going forward.
So, to kind of put a bow on this, the point here is to lower the barrier of entry, right? It's not to say that you're never going to have to write code again, that you don't need to know Python to do machine learning, right? That's not really what we're getting at here. It's just a very easy way to get a really solid start and save a lot of time, right? So I can go in here and I can have it train 30 different models while I'm out getting lunch, come back. You know what? 28 of them might be garbage. But even if 2 of them are pretty good, then, that sounds pretty valuable to me. So let's go back and do a quick recap.
So, like I said before, Glassbox AutoML. You get to see how it's configured, how it's being trained and evaluated. You can customize it and you can deploy it all in one place. And we're not trying to tell you that we're trying to take anybody's jobs. None of us are going to beat up a job anytime soon. And We'll move to our next slide. This is the different features that are currently supported in AutoML. We do have more on the roadmap, but these are the ones that you will currently find within Databricks as you log in at this time. Lots of different options, whether you're forecasting or you're doing regression or classification. And of course, a huge fan here of the SHAP values that you get for looking at your feature importances, all the pieces to help you do the entire life cycle with less of a headache.
And yeah,
Thank you very much. No questions?
How do we get our hands on it to give it a try? Is there anything within like Databricks Academy that can kind of walk you through how to use it, like a sample set?
Yeah, there is some training on the AutoML. There isn't any training on Bamboo Lib at this time, but there is their website, the 8080 Labs website, has a lot of really great videos and things available, so you can see what kinds of transformations you can do.
we also recently put out a blog, I want to say about a month ago. If you just Google Databricks AutoML blogs, that has the higher level messaging, but it also has an example notebook with data that it'll generate for you, and it'll walk you through kind of just take generated data, it'll already store it in the database for you, and you can just select, predict, and go. It's a regression example, so it's a little different than this, but it's ready to go.
Perfect. Thank you.
Thank you. Just a question. Is there a limitation to the size of the data set that AutoML can accept?
Yeah, so currently there are some limitations. And actually, if you remember that sidebar that he was talking about with the different versions of the ML runtimes, more recently in 11.0, your data sets can be larger. It's definitely on our plans is to make that as large as possible, but for now, your data is randomly sampled if the data is too large to run in a single experiment.
But to add to that a little bit, even if it's subsampled, right, you can get an idea of if the model is going to be good, hopefully, and that way you can take the auto-generated notebook, and that you're not limited anymore, right? So it's only the AutoML, auto-experimentation part that's limited, and that's because a lot of that hyperparameter tuning. But once you have the notebook itself, you can throw all your data at it.
Additionally, you would want to be careful if you have a huge data set and you run AutoML on it. That's a lot of experimentation. That compute could get a little wild if you're not careful.
Any more questions?
I just have one quick plug for our Databricks community. It's not as cool as Stack Overflow, but it's also very helpful. It's going to be our version of all the questions and answers that help you with things that other people have struggled with and have the answers to. So as you're spending in those hours during the day Googling for answers, check out the Databricks community as well. Thank you.
All right, thank you very much.